Okay, now I'm recording. So now I'm recording. Just open again. Okay, I'm recording already. Okay, recording. So let's continue this question about potentiometer. Figure 11, question 14. Right, figure 11 shows a simple potentiometer. Wire PQ has length 100 cm, resistance 2.4 ohm. PQ, this wire PQ lah. See that? This is the resistant wire. This is not a normal wire. This wire has resistance. Okay. So here he given the length of PQ itself, the whole. Oops. Okay, I know it. So the whole wire is 100 cm. 100 cm, and then the whole wire is resistant 2.4 ohm. I put like this, resistant PQ 2.4 ohm. Okay. And then the galvanometer shows no deflection when jockey is at X. No deflection means current equal to 0 ampere. Yeah, so the current is 0. Okay. When jockey is at X. So that means no deflection. Yeah, no deflection at when jockey is at X. So I can say that LPX is balance length. Balance length. Okay. Because why? Because it shows zero current. It shows zero current when the galvanometer. So many notification where I don't need it. So current shows zero reading. So this length this PX is balance length. Okay. 60 cm from P. Okay, so it is 60 cm. Okay. So by the way, if you look at this circuit, it is a little bit different from the previous example. Previous example is the top battery has longer wire, XY. You see, longer wire. Below is a shorter wire. The top one has a longer wire, but for this question, the bottom battery has a longer wire, not the top one. See, it's inverted. Can you see, class? This is important. This is important. You see this one, this example, the question 13, galvanometer below. But for question 14, galvanometer above. Galvanometer above. So, what I can say is, this circuit is inverted. Inverted compared to the previous example. Inverted. So, last time, the top one is a big battery. The below one is a small battery. Because big battery for longer length, small battery for shorter length. Okay. Top is big to small. But this one should be small to big. This one should be small to big. Because the top one must be small battery because it has shorter length. The bottom one must be a big battery because longer length. Okay, this one small to big. Right first. Small battery. Go below should be a big battery because it has longer length. Okay, bottom 2 volt is for PQ, the whole length. But for EMF, yeah, this one EMF B, EMF B. Okay, put below one, put EMF A lah. Yeah, below one is EMF A. This one is big battery. EMF B, the top one is small battery because has shorter length. Okay, should be smaller lah, the top one. So the top one cannot be more than 2 volt. It must be less than 2 volt. Maybe it's only 1 volt or 1.2 volt, like that. Yeah. Okay, so this is the balance length, 60 cm. Be careful. Here got a resistor. You see, here got resistor 1.5 ohm. So it's just like the example before. Okay. Later I will talk about this one. Okay. Now, by neglecting the internal resistance of 2-volt battery, okay, assuming this battery has no internal resistance, calculate the EMF B of battery B. So how? Actually, this question is almost the same as question B. Question B for part B of question 13, where you put a 1 ohm resistor in series with cell A. So something like this lah, something like this. 1 ohm resistor in series with cell A. Now this whole thing is at the bottom. Yeah, for question 14, is at the bottom, not at the top, it's at the bottom. 1.5 ohm in series with the battery 2 volt. So how to do? So again, use the same method like before. Yeah, if you still remember. So look at A first. Okay, look at A. So I can say, okay, before that, let us identify. So here you have, this, yeah, this one is voltage Px. Yeah, here you have voltage Px, and then some more. Okay, this part, oops, and this part is you have this part is voltage PQ. Yeah, voltage Px, voltage PQ. Okay, so what I can write about this is I can say when current equal to 0, Vpx equal to EB. Vpx is equal to EMF B. Okay, and then how about VPQ? VPQ is actually EA, but you have resistor here. If you have resistor here, that means it's EA minus IR. It is EA minus IR, just like the example before. Understand? The current actually flow in this circuit. There is a current flow here throughout the circuit below. Last time current flow at the last time the current flow at the top, right? This time the current below here, when balance length, no current, no current. So current at the top only. But for question 14, the current below here, the current below here at the top here, no current, yeah. Top here no current at all. So below, only below has current. So got current, current flow at the bottom circuit. Okay, so here got I lah. Okay, class. And then some more, I want to find the EMF B. So what I can do is the next step I can do is I have the balance length. I have the balance length LPX. Okay, so use like the method just now. LPQ, sorry, LPX over the whole length LPQ is equal to, this ratio, the LPX over LPQ equal to VPX over VPQ. VPX over VPQ. Okay, VPQ. So in fact, this below circuit is something like, I can redraw this whole circuit. If you look at the circuit below, it's something like this. Circuit below is like something like this. This PQ is like one whole resistor, and then here get another resistor. Okay, this is EA lah, EA, which is 2 volt. This resistor equal to 1.5 ohm, and this is the resistor what? Resistor PQ, resistor PQ, which is 2.4 ohm. The whole 100 cm. This is the whole 100 cm wire. Understand, class? Yeah. So he want this one. He want the the voltage across this whole thing. Yeah. voltage of VPX. Sorry, VPQ. VPQ. Yeah, voltage VPQ. So what I can say is here got current flow lah. Here got current flow in the circuit. You know, the whole current flow in the circuit. So I can say EA is actually current multiply resistor plus resistor PQ. Understand, class? Resistor PQ. So multiply, yeah, expand it, IR plus IRPQ. Okay. So EA minus IR equal to IRPQ. Understand? So IRPQ actually is IRPQ, current multiply RRPQ is actually VPQ. Understand? VPQ. Okay. That's why we got this. That's why we got this. Yeah. That's why we got this. VPQ actually is EA minus the IR. Yeah, the potential drop across this 1.5 ohm resistor. Yeah, you can put here. Actually, class, do you know that VPQ is also just, VPQ is also just very simple. That means it's just yeah, VPQ is also IRPQ. Yeah, we say this one. Yeah, okay. We say VPQ is EA minus IR. VPQ is also IRPQ. Yeah. Yeah. So you also can write, you also can find VPQ just using equal to IRPQ. Also can, yeah, also can, yeah. You also can. Okay. So it's the same lah. Yeah, it's the same. Yeah. But we must find the current first. We don't have the current. Yeah, we don't have the current. So we need to find the current first before we can find VPQ. So let's find the current. Okay. EA is actually 2 volt equal to I resistor is 1.5 plus this one is RPQ is 2.4. So what is the current? Let's find the current. What is the current? So let's find the current. 2 divided by 1.5 plus 2.4. It is yeah, I got 0.5128. Okay, 5128 is it? Yeah, ampere. So so the VPQ, so what is the, okay, yeah, so you can use this or that. Yeah, fine, it's the same. Yeah. Yeah, you see. Yeah, you just see. So this EA is 2 volt. 2 volt minus current is 0.5128. Just now we got it. 528 multiplied by 1.5. 1.5. What do you get, class? What do you get? 2 minus 0.5128 multiply 1.5. So I got 1.2308 volt. Or you also can use this, you also can use this 0.5128 multiplied by resistance PQ is 2.4. 2.4. You multiply, what do you get, class? You get multiply 2.4. See, I still get the same answer, 1.2307. Almost the same lah. Yeah, almost the same. Okay. So So, okay. Copy this, then you can understand. Yeah, copy this. Okay. So I need to find the EMF B. Yeah, EMF B. So LPX just now balance length is 60 cm. Okay. So 60 cm over the whole length is 100 cm. Yeah. Length PQ is 100 cm. This is just ratio, normal ratio, normal ratio. VPX is actually EB. VPX is EB. EB. Okay. And then VPQ is which one you want to use? Either one lah. Maybe I just use the below one, 1.2307. So I got my EB. That's why I got my EB. Very simple. 60 times 1.2307 divided by 100. Yeah, so I got my EB is 0.74 ampere. No, 0.74. Hold on. I think 738 volt. That's it. Very simple. Okay. Understand, class? Understand? Understand? You understand? Faham ke tak faham? Boleh lah. So many of you left the meeting. Line not stable. Okay. Never mind. I recording this video. Yeah. Problem. After that, you just copy lah, and analyze yourself. Yeah. Look one by one, step by step. Okay. Now, the ground meter and battery B now replaced with a voltmeter of internal resistance 20 ohm. Now he said this galvanometer and the battery replaced by a voltmeter. Voltmeter. Okay, with internal resistance 20 ohm. Calculate the reading of voltmeter if jockey maintained at the same position X. So what happened, class? Here he say replace the galvanometer and battery with a voltmeter. This voltmeter has resistance. That means this is no longer potentiometer, class. No longer potentiometer. It's just a normal, series parallel resistor in combo. No galvanometer, no battery. So just left with only one battery below. No battery above. Yeah, no battery above. Only one battery below. The whole thing above is just resistor only. Okay, let me redraw the diagram. I need space. Okay. So how should I draw it? Okay. B. So I replace the top one with a voltmeter. This voltmeter has resistance. That means it becomes something like this. Hopefully you can understand. Yeah. Let me redraw. So the top one no longer a battery, but it's just a voltmeter. This voltmeter, just put at the top here. This voltmeter has resistance. Just a resistance this voltmeter. Okay, and then here I divide into two parts. The wire I divide into two parts. Do you understand what I'm drawing? So this is resistance PX, and this is resistance XQ. I have to divide because later I want to carry out the series parallel resistor combo calculation. So this is the 60 cm wire. This is the 40 cm wire. Understand? This one is the 60 cm wire. This one is the 40 cm wire. Yeah, the whole length is 100 cm. Understand? I divide into this wire. 100 cm wire is just resistor. When you put the jockey at the middle, that means you cut the wire into two, into 60 cm and 40 cm. Okay, and then here, if you look here, this is another circuit. So actually, the circuit goes below here, and then here there is the battery, and then here there's another resistor, isn't it, class? Resistor R, which is 1.5 ohm, right, class? So I can actually redraw this, yeah, put this circuit to the top, okay, so it becomes something like so how should I draw it? So I can just, I think, just copy this, okay, and paste it. So I make a little bit modification. So this resistor go to the top. That means, because actually this resistor is series with the rest, isn't it? This resistor is in series with all the rest resistor. So I can, this one I mix a little bit modification, so it becomes over here, resistor 1.5 ohm. Actually it's like this. Always draw your circuit until you understand. Yeah, draw in a way that you understand the circuit. Yeah, redraw your diagram into the way you understand the circuit. This is what I encourage. And then below here is EA, the 2 volt. Okay, here is the EA 2 volt. Yeah, EA 2 volt. Okay. So this circuit lah. Now what you want to find? Find the reading of voltmeter if jockey maintained at position X. That means the jockey, the jockey is over here. The jockey is over here. Yeah, he maintained at position X. Here is at the position X lah. Yeah, at the X. So it maintained at 60 cm lah. Pendek kata, he maintained at 60 cm. He maintained at 60 cm length. So this is resistance PX with 60 cm balance length. Yeah. Okay, so what is the, he said this voltmeter has resistance 20 ohm. Yeah, so this one is 20 ohm resistor. Yeah, maybe I put this as resistance voltmeter lah. Resistance voltmeter is 20 ohm. Resistance voltmeter is 20 ohm, and yeah, that's it. But I don't know the resistance PX, resistance PQ, isn't it? At resistance XQ, I need to find what is the resistance. And some more, he asked to find the reading of voltmeter. Reading of the voltmeter. That means this actually is a voltmeter. Yeah. So what is the voltage? That means what I need to find. What I need to find the voltage across. I need to find the voltage across this one. I need to find this voltage. I need to find the voltage. So I need to find voltage VPX. Yeah, that means the voltmeter and the resistance PX combined. What is the voltage across this one? Okay, this resistance PX and the voltmeter, they are in parallel. So this is parallel resistor. So you need to find the voltage. To find this voltage, okay, I can give you a hint. To find this voltage, for voltage voltmeter with the resistance PX combo in parallel, so I need to find the current, the total current, because in this circuit it is the, it's the current, the total current passing through the whole wire. Yeah, the total current. Yeah, so current passing through is this. And then if I know the total current, and then I need to find the resistance voltmeter with resistance PX in combo. If I know this value, then I got the voltmeter reading. So I need to find the total current and also resistant voltmeter with wire px length px in parallel. Find the resistance in parallel. If I know these two value, multiply, I get the answer, voltmeter, voltage. Understand, class? Understand? Understood? Yeah? Are you listening? I wonder, are you listening? Where is the rest of students? Suppose we have 23 students, right? 23 students, that means here now you are only 16 students with me. Yeah, including, no, actually, only 15 students with me. Yeah, 15 students with me because including the presentation, that means only 15 students with me. So another 8 students sleeping. 8 students sleeping. Or you are sharing device, or is it? Sharing device, so good. Where is 8 students sleeping? Yeah? How come? How come you be like that? Huh? Now is that's the reason why you get a low marks lah in PSPM later. Huh? Why? Huh? Why like that? So, sharing device. Yeah? Your responsibility, what? Yeah? Your responsibility is just to study, to learn for your own good. Yeah? That's your amanah. That's why your parents send you here, Matric, to learn. You have to do your responsibility. Come to the class to listen. Not that because I will post this in YouTube and then you can escape class. Yeah, it's different. The way you learn, you listen. Yeah, the first hand compared to you listen second hand is different feeling. Yeah, I don't know lah. Yeah, this is the responsibility. Yeah, I'm scolding the wrong group of students. Yeah, I should actually scolding the person who didn't act, the person who actually should listen to my advice, not around. Okay. All right. So let's go back to this one. Okay. So this one, how to find? So I need to find this resistor PX, of course, and resistor XQ. So how? I have the whole length resistance. You see that? 2.4 ohm. That's for 100 cm. So if 100 cm is 2.4 ohm, what do you think is 60 cm resistance? You can find ratio. Understand? That means I can find resistance. I must find resistance PX first before I find the resistance in parallel. So okay. So that means resistance PX over the whole wire, resistance PQ, equal to, it's ratio, it's ratio, length of PX over length of the whole length, 100 cm. Just a ratio. So what is resistance PX? The whole wire is 2.4 ohm. Just now I got it. Not got it. The question given. Yeah. Question given, the whole length is 2.4 ohm. 100 cm is 2.4 ohm. So what about 60 cm? Find ratio lah. Okay. So length PX is just 60 cm. Length PX is just 60 cm. The whole wire is 100 cm. So I can find my resistance PX. So easy, class. This potentiometer, very easy question. Okay, so calculate. 60 divided by 100 multiply 2.4. What is it? 1.4. Oops, 1.44. I got it, class. I got it. 1.44. So, if I want to find resistance XQ, also can. I also need to find resistance XQ lah, actually, yeah. What do you think, class? Tell me how to find resistance XQ. Resistance XQ is the remaining 40 cm lah, isn't it? Remaining 40 cm. That means, okay. Resistance XQ, resistance XQ is the remaining resistance lah. out of the 2.4 ohm minus the 1.44. Isn't it, class? Resistance XQ is the resistance for the whole wire. Resistance for the whole wire minus the resistance of the 60 cm. Resistance PX. Yeah. This is for the 60 cm. Yeah. Now I want to find the 40 cm one. Yeah, this is for the 100 cm. Isn't it? So PQ is just now is 2.4 minus this 1.44. The remaining is, what is the remaining? Calculate. 0.96, isn't it, class? 0.96 kan? Or you also can put ratio like here. You put this 40 cm. You put if you want to find resistance XQ, you just put 40 over 100 multiplied by 2.4. You also get 0.96. Isn't it, class? Okay, understand, class? Understand? Okay, very easy only. Good. So I got the resistance SQ. So you must find the total. You must find the total resistance and then find the total current. Then I got the total current, and then only multiply by the resistance of this parallel circuit, parallel resistor. Then I then only I can get the voltage across the voltmeter. Yeah. Find the total resistance first. Total resistance. So okay, do one by one. Okay, first find these two must combine first. Voltmeter and the resistance PX must combine. They are in parallel. Parallel means 1 over 1 over R VPX equal to 1 over resistance of the voltmeter 20 ohm plus 1 over resistance of the PX. Just now we got it 1.44. So the voltmeter is 20 ohm and PX is 1.44. So resistance VPX, don't forget you must terbalikkan. Ramai orang lupa untuk terbalikkan. Okay, cuba cari. 1 over 1, this 1 over 20 and then plus 1 over 1.44. Okay, and then I got it, and then 1 divided by answer. Okay, so I got 1. The answer is 1.3433 lah. 1.3433. Okay, ohm. Okay, then what's the total resistance? The effective resistance, we say, is the effective resistance. The total resistance. Effective resistance is resistance VPX plus, because now they are all in series. They are all in series. Just now is parallel, not in series. And the resistor R. So what is the answer? 1.3433 plus resistor XQ. SQ is 0.96. Yeah, 0.96. And then the resistor 1.5 ohm. So what is the answer, class? Okay, 1.3433 plus 0.96 plus 1.5 go to 3.8033 ohm. Okay, I got it. Yeah, I got it. So I got the total resistance. I can find the total current. Total voltage equal to, total current, total resistance. Yeah. In fact, this total voltage is the EA. Resistance, the total is the effective lah. Okay. So 2 volt. Yeah. Total voltage is 2 volt. Okay. And then the total, I need to find the total current. I need to find it. resistance effective is, the total resistance is 3.8033. Okay, so I got my total current. Let's find it. Total current 2 divided by 3.8033. So what is the answer? So it's 0.259 ampere. Yeah, I got the current already, total current. So how to find the voltage across the parallel? So the current, total current passing through this parallel resistor, passing through. So it's the current total. So okay, let's find it. So voltage, that means I use this one lah. Yeah, this one. Yeah, I need that one. Okay. So now this one lah. Excuse me. Here, yeah. So I need to find voltage VPX. Yeah, voltage VPX is equal to the total current, which is 0.5259 multiplied by resistance VPX only. I want resistance VPX only, which is 1.3433. 1.3433. So multiply. What answer did I get? 0.5259 multiplied by 1.3433. So what's the answer? Yeah, 0.71 volt. I got the answer. 0.71 volt. Huh? Is the answer correct? Huh? Is the answer correct? Let's check. Yeah. Let's check the final answer. Question 14. Bottom line answer. Question 14. Yeah, see that? 0.71. 0.71 volt. It's correct. 71 volt. It's correct. 0.71. Yeah. Just now, the previous one, EB is 0.74. 0.74. Is it correct? Yeah, EB is 0.738. Yeah, 74 lah. Correct. 0.71. Okay, I got it, class. Understand? Yeah. Okay, so far so good, Am I recording? Yeah, I'm recording, yeah. How many still with me? Baru bangun, ada orang baru bangun. Okay, so alright, so okay, that nanti you tengoklah langkah ni, ya, langkah ni. Okay, so ada lagi satu soalan kan yang kita, dua soalan lah kita belum bincang, ya. Ada lagi dua soalan kita belum bincang. So soalan yang kita belum bincang ialah soalan 8 sudah kan? 8 sudah, 9 sudah, 10. 10 dan 11. So kita habiskan dua soalan ni, ya. We finish these two questions. 11 dulu lah. 11 dulu, ya. Question 11 first. Okay. Today we just finish this chapter 3 lah. Okay. Because then that's all lah, yeah, for today. Yeah, just finish these two questions. Okay, so come, yeah, let's do this. Okay, so look at this. A toaster has a heating element made of nichrome wire and connected to a 220 volt source. The wire is initially at 20 degrees Celsius with current 1.8 ampere. When the toaster reaches a final operating temperature, the current is 1.53 ampere. Determine the power delivered to the toaster at the operating temperature. Okay, so how? Connect to this voltage, initially 20 degrees Celsius, has this current. Now toaster increase, I think the temperature increase. Yeah, of course temperature for toaster should increase. Yeah. initially 20 degrees Celsius. It must increase to 100 degrees Celsius or above. Toast the bread. Yeah? So when the temperature increase, current decrease from 1.8 decrease to 1.53. Why? Why current decrease? Because resistance increase. When temperature increase, resistance increase. Resistance increase, current decrease. Remember? Determine the power delivered to the toaster at the operating temperature. So what is the power delivered to the toaster? So how to find power? Power delivered to the toaster. So power delivered, the formula. Okay. So power delivered, question A. Power delivered. I have the voltage, power delivered, or power supply lah kan. Power supply. Normally I use a formula IV. Understand? IV. So power delivered at the operating. Oh, I have the current, isn't it? I have the current. I have the voltage. So IV lah. Current. The final at the power delivered at the operating temperature. This one at the, I think power delivered at the final operating temperature lah. Okay. So just take the current 1.53 multiplied by 220 volt. So what's the answer? 1.53 multiplied 220. So the answer is 336.6 watt. Yeah, that's the answer. Okay. Now question B. What is the final temperature of the heating element if the temperature coefficient of resistivity for nichrome wire is this? This is alpha, yeah? Alpha value. Temperature coefficient of resistivity is alpha. So the question asks for final temperature. That means you want the final temperature. Yeah, final. So I can use the formula, the formula. Remember the chapter 3? We learn about this. The resistance versus temperature. Resistance versus temperature. Where is it? Yeah, come on. Nah, see? No. For that. Nah, this one, see? This one, use this formula. Okay? Use this formula. So R equal to R naught 1 plus alpha T minus T naught. Okay? But I don't have resistor, right? I don't have resistor. I only have current. Never mind. Okay? Initially, initial temperature. This is initial temperature. So this is a T naught. Initial temperature is T naught. And this current just put as I naught lah. Yeah, initial temperature and initial current, and then this is the final current. Final current at final temperature. Understand? So this formula V equal to IR. So V equal to IR. So R is actually V over I. R is equal to V over I. So if R, if let's say initial resistance, then will be I naught lah. If final resistance, then final current. Initial resistance, initial current. Understand? Initial current. So I can change this. Into V over I. And then initial resistance become V over initial current. V over initial current. And then 1 plus alpha final temperature. Yeah, that's what I want to find. T minus T naught. Then you substitute all the all the information. This 220 volt over current, final current is 1.53, equal to initial. Okay, voltage is the same, but the current initial is 1.8. 1.8. Okay, 1 plus alpha. Alpha is 4 exponent negative 4. 4 exponent negative 4. And then final temperature, final temperature T minus T naught. T naught is 20 degrees Celsius. 20. Okay, so I got my temperature. Wow, this one I need to calculate. I can actually I can, this temperature is the same. I can cancel. So what do I get? Okay, so what I get is this one. Actually you can just multiply this to the top. Yeah. So 1.8 divided by 1.53. That's it. And then minus 1, and then divide by 4 exponent negative 4. 4 exponent negative 4. And then I plus with 20. Yeah, so the temperature is 461.18 degrees Celsius. Yeah, this one is 20 degrees Celsius. So this one is final temperature is 461. Is it correct, class? Let's check the answer. Yeah, let's check the answer. That is question 11. Question 11. Let's check question 11. Yes, question 11. I got the initial question is question A, 337 watt. 336.6. Yeah, 337 watt. Yeah, correct. And temperature, final temperature is 461 degrees Celsius. 461 degrees Celsius. Correct. Okay. Understand, class? Understand? Okay, nice. So the last questions. Yeah. The last question. Come on. Last question. Which is question 10. Question 10. Question 10. So I need. Or you can do on your own, right? Coach of Law, I taught you already. Never lah. Still have time. 34314. Okay lah. Yeah. More than 1 hour of Google Meet. Anyway, it's holiday. It's almost holiday. So can have some rest. Yeah. Me, I need to packing everything. Yeah. Prepare my family. A lot of works as a family. A lot of works. Packing, not just. Yeah. Go along. Check in, check out of the tickets, everything. Everything have to check. Prepare. No rest. No rest. Okay, so let's look at this question 10. Yeah, question 10. Okay, so this is our last question. So always I would like you to draw, draw the whole circuit. Yeah, again, draw the whole circuit again. I would like to draw the whole circuit first, for a bigger, easier. Oh, this one send sunset back. Okay, nice. Now, Please redraw the circuit in your answer script. Yeah, please redraw this circuit on the. Please write. Please always draw circuit. Draw and label. Draw and label circuit at answer script. Yeah, at answer script. Because your lecturer want to refer. Yeah, your lecturer want to refer to your circuit to mark the all the equations. Yeah, because he want to compare the direction, same direction positive, opposite direction negative. Compare the EMF direction with the loop, same direction positive. If compare the resistor current with the loop also, same direction positive. So lecturer want to know all the positive negative. They want to compare directions. So they want to look at your circuit. They want to refer to your circuit. So always draw and label the circuit at your answer script. Okay must draw jangan tak lukis So now look at this current. So how are you going to do? First step, you label all the, you must label all the EMF, label all the current at the resistor, at the junction, so that we can know current in, current out, and then we can know compare EMF with the loop, compare the current resistor with the loop, to know positive or negative. All those lah. That's why you need to label first. Okay, negative to positive. So the EMF is this way. Negative to positive. So the EMF is this way. Okay. Current I1. Okay, I1 passes through 16. So label I1 over here. And then I1 passing through the 25 ohm. Okay. And then entering here. Entering this junction. Okay. Maybe you can put this junction as junction B lah. Junction B, yeah. Junction B. What more? I2. I2 entering junction B, yeah, and then exiting from junction A. Here there is no resistor, no resistor, just battery. And then here I3 passes through 18 ohm. Draw label I3 passing through 18 ohm, and then I3 actually come out from junction B. Okay. So now I can find the current. So how to find the current? I don't know all the current. So how? I think you do. Maybe you do. This. Wait. Maybe you do junction A lah. First, you start with junction. First law. Junction A. So first law. This is first law. Total current in equal to total current out. Total current out. So current in is junction A is I3, and then become I1 and I2. So I3 come in, and then going out is I1 and I2. I1 plus I2. I1 plus I2. Okay, I3 go in, and then I1 and I2 come out. Okay, junction current out. Okay, that's one equation. And then for okay, so loop, choose a loop. Maybe I choose the loop, this one loop. I look at here, I think this loop is better because here has no resistor. So I can avoid the I2R. There's no I2R here. There's no I2R. So the equation only will have only one I1. Only I1. I can straight away find I1 using this loop. There's no I2 if I choose this loop. Yeah, because no resistor here. Very good. So that means I choose this loop. I use anti-clockwise. Put as loop 1. Okay. So loop 1 equal to total EMF equal to total IR. Okay, so what battery? You have two battery here, 18 and 12. 18 is same direction with the loop. Same direction, so it's positive, positive 18. And then 12 is opposite. You see, going down, this one going up. So opposite, so it's minus 12, negative 12. Understand? Okay, next. IR, you have 16 ohm and 25 ohm. Here, I2 don't have, don't go to put I2, just I1 only. So 16 ohm and I1. So also same direction, I1 with the loop same direction. And then this one, 25 ohm, I1 also same direction. So both are positive lah. Both are positive. So 16 I1 plus 25 I1 because both of them are same direction with the loop. And then don't go to say, oh, here I2 must also have. Then you go to put another plus I2 here. Yeah, is it correct, class? Like this? Is it correct? No. Kalau tiada resistor, tiada lah. Tiada. Jangan suka-suka hati. Oh, letak kalau tak ada resistor, letak I saja. Ya, ada pelajar macam itu, kelas. Pelajar macam tu. Tak boleh. Kalau tak ada resistor, memanglah tak ada IR. Tak ada. Ya, dia macam I2 multiply 0. Multiply, tak ada resistor. Tak ada resistor means resistance 0. So, dia become plus 0. Bukan plus I2. Okay, class? Understand? 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 Jangan suka-suka, oh, kata setiap branch mesti ada, ya. Kalau ada branch, kalau I1 ada, I2 pun mesti ada. Tak ada, bukan macam tu. Bukan kata semua current mesti ada, tak ada. Kalau tak ada resistor, means tak ada lah. Jangan pula tulis plus I2 saja. Salah tu. Kalau plus I2 saja, maksudnya you assume itu resistor darab 1 ohm. Maksudnya masih ada resistor 1 ohm. Ya, you assume macam itu, tak boleh. Kalau tak ada resistor, means dia punya macam I2 darab kosong. So dia macam plus kosong je. Means tiada lah, tiada I2. Okay, Don't go to put like that, So that's why I choose this loop because I know that it will only give ada satu variable je, I1 je. So senang kita terus dapat nilai I1. Terus kita dapat nilai I1. Okay. So berapa I1 ya? So berapa? So ini 18 tolak 12 6 lah. So ini jadi apa ya? 16 tambah 25 ya? 41. Okay, it's 41 I1. So what is I1? 6 divided by 41 is 0.146 ampere. That's it. 146 ampere. And now how about this is the second equation already. Yeah, second equation. Now I need one more equation. I need one more loop. I think I can use this loop lah. Yeah. I think this one also I choose anti-clockwise loop. So this loop 2, So let's do loop 2. Loop 2, total E equal to total IR. Okay, so what battery you have in loop 2? Loop 2, that means I go from here down and go to right, go up. This one loop lah. So in this loop, you have one battery only, one battery. So one battery saja. So this battery same direction, so positive lah. So dia positive 12. Itu saja kelas, senang je. And then resistor ada berapa? Ada satu saja. I2 tak ada lah, ya. I2 tak ada. So memang tak ada. Jangan pula letak plus I2, ya. Jangan. So I2 tak ada, cuma ada I3. I3 ada resistor. So ini ialah ini 18 ohm. Current dia I3. And current dia same direction with the loop. Kalau same direction, positive. So positive 18 I3. Itu saja. Habis kelas. So boleh terus dapat I3. Terus dapat I3. So I3 berapa? 12 divided by 18. So it's 0.667 ampere. So I got it. So back to equation 1, your Kirchhoff first law, current in, current out. I can find I2. So I3 equal to I1 plus I2. So I3 is 0.667 equal to I1 is 0.146 plus I2. So what is I2? What is I2? Yeah. So 0.667 minus 0.146. Okay, 0.521 ampere. That's it, class. Very simple. Yeah. Okay. Now, question B. Yeah, look at question B. Question B. Now, what is the potential difference across the 18 ohm resistor? 18 ohm resistor. 18 ohm resistor. That means this one. What is the potential difference? That means the voltage. What is the voltage across 18 ohm resistor? So V go to IR only lah. IR. But I guna I apa? I apa current yang lalu 18 ohm? I3 kan? So make sure you use the correct current I3. Jangan guna salah. So I3 is 0.667. I3 is 0.667. Multiply resistor 3 is 18. So what is the voltage? 0.667 multiplied by 18. So I got 12 volt. 12 volt. That's it, class. Is the answer correct? Let's check. This is a question 10. Question 10. Let's check the answer. Yeah. Question 10. Question 10. Yeah. Okay. 10. Okay, let's look at question 10. There's the question 10. Question 10, see that? It is, let's check. 0.146 I1. I1 is 0.4. Yeah, correct. 0.146. And then I2, 521. 521, correct. 667. I3, correct. 12.01 volt. 12.01. 12 lah. 12.01. 12 volt. Okay lah, almost. Okay? Understand, class? I got it. Okay. Okay, class, one more thing. Let's say if class, if you get the answer I2, let's say this is notes, please write notes. If let's say you get I2, your final answer, let's say you get final answer I2 equal to negative negative value. What does it mean, class? If you have negative value, let's say if you have negative value, what does it mean, class? This negative means please write this down. Okay, to make this phone bigger. Okay, that means the actual current direction is opposite to the direction drawn. Okay. So you must write in bracket this one. It's opposite to the direction drawn, the actual one. That means kalau let's say the question give you the current is in this way. Bukan ke bawah, tapi dia bagi current direction ke atas. So you mesti akan dapat negative value. Maksudnya the actual current direction is opposite to the one given, opposite to the direction given. So current sebenarnya bukannya ke atas, tetapi sepatutnya adalah ke bawah. Oops, salah saya. Bukannya ke atas, sepatutnya ke bawah. Tetapi you lukis salah, you lukisnya ke atas, ya? Atau soalan bagi salah, dia bagi ke atas. Tapi you dapat negative value, maksudnya current direction is actually not going up, it's actually going down. The actual current direction is opposite to the direction drawn or direction given. Understand? Opposite. So kamu kena dalam bracket kena tulis inilah. Kalau you dapat negative value lah. Okay? So that's all. Yeah, you understand, class? Understand? Boleh ya? Okay lah, I think that's enough lah. Ya, sebenarnya pun dahaga sudah. So mungkin esok pun terpaksa saya limau kah? Nak limau? Limau. Nanti CNY lah. Nanti CNY ada sambutan Chinese New Year dekat Dewan Mutiara tu. Datang lah ya. Ada show dekat situ ya. Okay, baik. Okay lah, I think that's enough. Tu esok pun mungkin terpaksa online sebab saya kena jaga anak di rumah ya. Terpaksa online, so kena jaga anak di rumah lah. So kalau esok akan masuk chapter 4 lah ya. So itulah. So okay lah ya. So I think that's enough for today. Okay. So nanti saya post dekat YouTube lah ya video ni ya. Okay, thank you for listening. Okay. Okay. Bye.
Bye, sir. Thank you, sir.
Thank you, sir.
Okay, thank you.
Thank you, sir.